Hi everyone! With Project Next Generation classes at the Elmwood Park Public Library on hiatus, I thought I'd give you a look at what I've been up to while the library is closed. For those of you who may not know, Project Next Generation is a series of technology classes that I teach at the Elmwood Park Public Library. All of the equipment, computers, and supplies are paid for with grant money from the Library Services and Technology Act, which is overseen by the Institute of Museum and Library Services. The money is administered in the form of a grant through the State Library of Illinois and the Office of the Secretary of State of Illinois. The grant is called Project Next Generation, and as a recipient, we use that money to buy supplies, gadgets, and cool technology to put on awesome programs and classes at the library for teenagers. One of the classes that we frequently teach at the library is a 3D printing and Tinkercad class. Tinkercad is an online 3D design program that allows you to create 3D models and then use the 3D printer to print those objects out. Over the years, the library has used our PNG grant money to buy 2 3D printers. And even though the library is currently closed, we've been staying busy using our largest 3D printer to help manufacture components for face shields for use by our medical workers. I'm not making the full face shield, but rather I'm using the library's 3D printer to create a large plastic piece that is central to the face shield. There are a bunch of different designs out there, but this is the one that we're currently using. I say we because we linked up early with a group of about 40 local 3D printer operators and hobbyists thanks to a tip from our business manager, Maureen. This group is headed up by Rob Parks from Oak Park, who has dubbed us the Noble Army. So we make the frames and drop them off at Rob's house, where he and his family add the plastic sheet and elastic or rubber band and then deliver them off to area hospitals, clinics, and whoever else needs them. As of this recording, we've made and delivered almost 5,000 completed shields, and the Elmwood Park Public Library has contributed over 100 frames. Each frame takes about 3 hours to print, and we've had our 3D printer working about 18 hours a day, every day of the week. The Noble Army has delivered completed shields to Gottlieb Memorial Hospital, Loyola, McNeil, Rush Oak Park, Mercy, Advocate Lutheran, Edward Hospital, West Suburban Hospital, Loretto Hospital, Norwegian American Hospital in Humboldt Park, Garfield Park Hospital, Mount Sinai Hospital, Jackson Park Hospital, St. Anthony's, St. Bernard's, Lawndale Christian Health Center, Roseland Hospital, Central Nursing Home on Central Avenue, Belmont Village Nursing Home, Generations Nursing Home in Elmwood Park, Metropolitan Family Services, Chicago Food Pantry, Evanston Police and Fire Department, and most recently, the Cook County Sheriff's Department. We've also provided shields to many other small clinics, dentist's office, optometrists, a residential facility for the developmentally challenged, and we've gotten inquiries from as far away as Dallas, Texas, Hanover Township, Pennsylvania, and South River, New Jersey. You've probably seen and heard talk of 3D printed shields on the news, but you might be wondering, what does it really mean to 3D print something, and how does it work? Well, let's get into it right now. Everything that gets 3D printed starts with a computer file. The computer file contains a 3D polygonal model and all of the instructions that the 3D printer needs to print it out. There are lots of different types of file formats out there, but this one is a .stl file. We take that .stl file and we load it up in our slicing software. In this case, we're using the program MakerBot Print to slice our file. Slicing is exactly what it sounds like. The computer takes the 3D model and slices it into horizontal layers and calculates the path that the extruder will take when it's building up the layers on the print bed. Hold up, okay, extruders, print beds, what are we talking about here? The simplest analogy is to think of the 3D printer as a hot glue gun on a gimbal. You're probably familiar with a hot glue gun, right? The gun heats up and melts the glue, and then you squeeze that glue onto a surface. Well, in this case, the gun is the extruder. The glue is the plastic filament that comes in a roll like this. And the surface is the print bed, or sometimes referred to as the build plate. The build plate moves up and down, and the extruder moves side to side and back and forth, and together they build a 3D object out of plastic layer by layer. It's a slow process that can take hours. These frames that we're printing take about 3 hours each to print, and on a good day, if I get up early enough and time everything right, I can get about 5 frames printed a day. After the print is finished, I remove it from the print bed and I start a new one. While the new one is starting, I separate the raft from the print and clean it up. Raft is slang for base layer. Not all 3D printers require a raft. The raft is used to help adhere the object that you're printing to the print bed or the build platform. A lot of printers have a heated build platform which helps keep the object stuck to the print bed, or some require you to put down a thin layer of glue. We can't really do that on our MakerBot, so we use a base layer, sometimes called a raft, instead. When the job is finished, we snap off that raft. All the little stringy bits that you see are a byproduct of the extruder moving back and forth and trailing a little bit of filament behind it. These strings don't always appear. It just depends on your printer settings and the 3D model that you're printing and the temperature and humidity in the room. They're easy to remove with a small file and a little bit of elbow grease. I ran into a challenge with our MakerBot when we switched over to a new style of frame. The new frame was just slightly larger than the old frame and was butting up against the limits of how big we can print on our particular MakerBot. Since we don't have the heated print bed on our old MakerBot, sometimes prints can cool unevenly, and when that happens, the bottom of the print object can sometimes curl. Depending on what you're printing, this can be a minor annoyance or it can be a huge problem. For this particular design, the curling was occurring around the part of the frame where the visor is attached. So if it doesn't turn out correctly, that's a big problem. I struggled with finding a way to print the new frame design for about a week. Eventually, I discovered that if I printed the frame 2 millimeters above the surface of the build plate, the computer would automatically insert temporary breakaway supports. I always tell my students during 3D printing class to avoid those breakaway supports at all costs, but in this case, they saved the day. The supports lifted the print up off the build plate high enough to negate the effects of the curling. The only downside was that removing the supports required about twice the cleanup as the original frames. It's especially important to get these cleaned up nicely because they're going to be sitting on someone's head. Any bump or burr or jagged edge is definitely going to be noticed when it's poking into your forehead. After I get all the frames cleaned up and I've collected about 20 of them, I bag them up and take them to be delivered to the house of our organizer, Rob Parks. I leave them on his porch, and when he gets them, he puts them in a bath of Clorox bleach to disinfect them. Then he attaches the clear plastic shield and the elastic strap, and after that, he fulfills the orders to anyone who needs them free of charge, and he's getting new orders in every day. So that's what we've been doing here with our PNG 3D printer. We've got lots of filament left to go through, and we'll keep on cranking out these frames until we hear otherwise. If you have a 3D printer or materials you'd like to donate to the cause, or if you're interested in procuring some shields for your organization, you can send Rob an email at covid19shieldop@gmail.com. Thanks to the Illinois State Library and the Institute of Museums and Library Services for funding this 3D printer and enabling us to contribute to our community. And thank you for watching. If you have any questions, please let me know in the comments.